Yes, this was that topic what we discussed last time. Actually, we discussed a lot about diffraction, that refractive index. Got it? The major focus in the last lesson was actually how to calculate refractive index and what is the function of refractive index during refraction. So that was the detailed discussion about refraction. Today we will discuss about that what is the total internal reflection, right? It is a part of refraction, but we have to separate that out. That is total internal reflection. Total internal reflection. Got it? So total internal reflection is basically when we say that the light, instead of going to the other medium, or instead of refraction, light reflects back in the denser medium, is called your total internal reflection, right? I will write and then I will explain it to you, right? So instead of, when light enters from more denser to less denser medium, when light enters from more denser to less denser medium, instead of refraction, more denser to less denser medium. So instead of refraction, yeah, instead of going out, instead of refraction, it reflects back inside the denser medium. It is a bit detailed definition of that. Inside the denser medium, that is called your total internal reflection, denser medium. Got it? So I will just show a demonstration, or a small diagram for that. That, for example, if I have a glass block and I'm going to incident a light ray over here, and this light ray is not getting out of this, it is reflecting back over here. This is called my total internal reflection. Is it clear now that what does it mean by total internal reflection? That
Yes.
all the light is back inside. So this is a glass slab. So when I throw some light over there, the light, instead of going out of that glass slab, what happened? It reflected back. Okay, that light reflected back inside. So following the laws of reflection, so this is the I, and that is theta r. So this is how that we explain this. There is another example. For example, if I have a structure like a prism, like this, and if I'm going to throw a light on that from here, so it should go out, is it? But sometimes at specific angles, I mean at certain angles, suitable angles, it does not. It is total internal reflection. So here we say that, oh yes, light is reflected back. So this is what this all is considered to be total internal reflection, and we deal this total internal reflection in different ways. So let's say this is the normal over here, and if I say the light is entering, so this is your angle of incidence and this is your angle of reflection. Now is this clear? What does it mean by total internal reflection? Or in it, there is another example. If you people know about the optical fiber, did you ever hear about the optical fiber?
Yes.
So in optical fiber, light does not go out, it reflects back inside, it bounces back inside in this way, and this way it goes out over here. So this is also a game of internal reflection, total internal reflection. So there are so many applications in which we can say that total internal reflection can be observed from the light. So should I continue with this application area now? That what are the conditions for internal reflection? Or before that, let me talk about critical angle, because there is a term which is used over here, critical angle. Ariba, can you tell me what does it mean by critical?
Critical is necessary or extremely important.
For example, if I say that, oh, there is a person who is in critical condition, what does it mean? Or we can say, I'm facing very critical condition or critical situation.
Uh,
What does it mean?
Something that would be, for example, maybe very reproving or crucial, basically, or grave.
Yes, we are unable to decide what will happen, or we are unable to predict what will happen next. That is critical. Yeah, yeah. Do you agree with this statement?
I mean, you know what happens at critical angle, totally internal.
Yes, we do not know whether in reflection will happen or refraction will happen. So critical mean unpredictable. Okay,
Okay.
unpredictable position or unpredictable situation. So when we say that critical angle, an angle in the denser medium, an angle in or you can say an angle of incidence. Rather, I will write in this way: an angle of incidence in denser medium at which the light ray becomes parallel to the boundary of the medium. Parallel to boundary means neither it goes out, neither it comes in. The light ray becomes surface of medium. Surface of medium in which we are basically from which we are going to emerge the light out, or you can say emergent light ray, in which the emergent light ray, this would be good over here. Emergent light ray, I mean the light ray which is coming out of that medium, it becomes parallel to that. So neither refraction takes place, neither refraction nor reflection takes place at that angle. Neither refraction nor reflection takes place at that angle. Now is it clear?
Yes.
Takes place at the angle of at the critical angle. At the critical angle. So I can say that if I draw that angle on a surface, let's say this is a boundary and we have to draw an angle over here. Wait, I don't know how to draw this semi curve over here, but let's say this is a semi curve. So let's say I'm going to incident a light ray over here. ये देखो. So that light ray is incident over here, and the emergent light ray becomes parallel to the boundary of that surface. ठीक है? This is basically the normal at which this light ray is incident at this point. Okay, so I can say that this is the normal to that surface, this one. Above देखो, this is the angle of incidence, and this is the angle. I cannot say that is refraction or reflection, but because the light was refracted first, so I can say that is theta r is equals to 90 degree, or theta 2 is equals to 90 degree in the medium. This is your theta 1, and that theta is called your critical angle. What do we call this angle? Critical angle. So that angle of incidence at which refraction or the angle of the emergent light becomes 90-degree with the normal, or the light becomes parallel to the boundary. Got it? Are you getting this thing? Let me draw the red one so आपको नजर आ जाएगी. So this is the light ray which is normal to this, or normal to the I mean at 90-degree to the normal, or parallel with the surface. So is this clear? This angle is called your critical angle. Got it? So total internal have some conditions. Conditions of total internal reflection. Total internal reflection. That is, if angle of incidence will be greater than critical angle, then total internal reflection will take place. When angle of incidence will become greater than critical angle, then total internal reflection takes place. Total internal. This is asked to you. That's why I'm going to write in words, proper words. Internal reflection takes place. Okay. So if I say that, if I explain it in another way, so I will write this, that if a light enters, or if a light um, leaves the glass at an angle greater than critical angle, then it will not leave it, rather it will come back to that. So if a light ray incident at an angle greater than critical angle, greater than critical angle, then what will happen? Then it will not refract, it will not refract in air, but it will come back to the glass. But it will come back to the glass, or it will come back in denser medium. Are you getting this thing? So I will draw a diagram for that one over here. Let's say, if I say that this is a semicircular disc of some plastic or whatever that is, whatever is critical angle, here I have to draw normal over here at this point, and then I will draw a line at this position. This is the normal. Now I'm going to incident a ray at this point. Let's say this is a light ray which is entering over here. Then I will draw another light ray which is entering over here. This one. And then I will have another light ray which would incident over here. So basically I have incident three light rays. Okay, blue, red, and green. Okay, so remember this thing. This angle is, this blue one is the angle, let me call it theta I. This red one is your critical angle, let me call it C. And this green one is, let's say, another angle theta I. Okay, so if I write the conditions over here, or you can say this is theta 1 and this is theta 2. So theta 1 is less than critical angle, and theta 2 is greater than critical angle. So what do you suggest? What do you suggest for blue light and red light and green light? What would happen to them? Yes, Ariba? What will happen to the blue light?
I'm still confused, sir. I'm still thinking about it.
Okay, yeah, yeah. What about you?
So the one that is smaller than the critical angle will just get refracted, and the
Yes.
one
Dekho,
larger
Ariba?
than
Okay, good, good, good. Explain it.
and the one that has larger incident angle than the critical angle will get
Mm-hmm.
total internal reflection.
Hmm. Yes. So, Ariba, I was talking that this green is at angle greater than critical angle. Is it? Are you agreed with this or not?
Yes.
So I told you that if angle of incidence will be greater than critical angle, instead of getting out of the medium, the light would come back. So this green will come back. What about the red one? Red is exactly critical angle, so it would become parallel to this. Okay? Now is it clear?
Yes.
So this is your critical angle. So it would go in this way. And what about this one? Blue one. Blue one will perform refraction. Normally refraction. So refraction means this way. Got it? So this would be refracted. Refraction. This is nothing. You cannot say neither a refraction nor a reflection. So I mean it is critical situation. Are you getting this thing?
Yes, sir.
And now this green one is your total internal reflection. Now is it clear?
Yes, sir. Thank you.
Okay, welcome. So I can say that in condition number one, yes, well done, yeah, yeah. You are also contributing very well. So theta one is less than critical angle. So refraction will take place. Refraction takes place. Okay, Ariba, is it clear to you as well?
Yes, sir.
And here, this theta 2 is greater than critical angle. So total internal reflection takes place. Total internal reflection takes place. Okay. Any confusion till this point?
No.
Okay, good. So I can say this is basically light entering over here, and this was the light entering from here. Okay, now my next stance or next step is calculations of critical angle. Calculations of critical angle. These are asked to you. A lot of calculations are asked in exam related to this critical angle. So you have to know that critical angle is basically equals to sine of 1 upon n. I will show you how did I write that. Remember one thing, when you are talking about critical angle, let's draw this diagram again. This one. From this, I will explain to you that whether why I'm going to use this equation or how do I use this equation. This is your glass lab, okay? And in this glass lab, when you are going to incident some light from denser to rare medium like this, are okay over here in this way. Light is entering from this point over here. So here is the normal. This is the normal. Okay. And this light would bend, or it this light would pass at this angle. I mean to say that it would become parallel to the surface of the glass. Now, this is your critical angle, and this is your angle which is equal to 90 degree. So if I use some calculation techniques over here, can I say this is your incidence angle? And can I say that, okay, it is your angle of refraction? Or should I say that because light is getting out of that, so I can consider that it is refraction, or minimum angle at which refraction will take place? So I have to say that when the light is entering from denser to rare, so what is the path of light from denser to, I mean from glass to air? Glass to air. Okay, yeah, yeah. Tell me, when light enters from glass to air, how do we use that formula of refractive index? N is equals to,
What?
when light enters from glass to air, how do I use that formula of refractive index?
Oh, sine I divided by sine R.
And Ariba, what about you? Can you tell me, please?
I think it's also the same. This is the one equation I know. Sin I divided by sin R.
No, no. This was that. Both of you are incorrect. Okay, listen. This is from denser to rare. That's why I told you that it would be inverted. Remember this thing.
So inverted means that the equation would flip?
Yes, it would be flipped.
Oh,
Okay?
right. Okay.
Yes, because the path of the light is flipped. Light is normally light enters from air to glass. So we use sine I by sine R. But here it is flipped. So it would be sine R by sine I. So if I say this is N and R is 90 degree. What is this? Sine R is 90 degree. And what about this I? This is your critical angle. Can I write these things or not? Because here, check this one. That is 90 degree. And this angle of incidence is your critical angle. So can I name these angles, or can I put the values for that? So, yeah, yeah. What is the value of sine 90?
Yes, sir. Yes.
What
Sine
is the
9,
value of sine 90?
1.
Okay. Ariba, do you remember? Do you know this thing? Or
I haven't gone this far
Oh,
in my.
wait. No, no, no. Sorry, it's not 1.
are you going to log it? Calculator se karo. You are right. It is
Wait.
90.
Oh, yes, it.
It is
No.
90. Yes. Ariba sin 90 होता है. Calculator से calculate करो. Sin 90 put करोगे, you will get one answer. Okay?
Wait.
Okay.
Why does mine doesn't give that?
Your
Oh,
calculator
wait.
is in radian.
Yeah. Yes, 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 yes.
You know, in the last lesson, we did the same. Your calculator was probably in the radian. Okay. So here sine 90 is 1. So I can say that n equals 1 divided by sine c. This is one of the equation which links critical angle and your refractive index. And if I say, if I cross multiply that, I mean, if I make sine c a subject, then sine c is equals to 1 upon n. Sine c is equals to 1 upon n. So yes, it is sine inverse. Sorry, maybe I was mistaken. So sin c का formula क्या है? Sin c is equals to 1 upon n. So please recall these equations. These are very important equations. Recall both of these. Okay. And when you are going to find c, c will be equals to sine inverse. In your calculator, you have a function of sine inverse 1 upon n. So you can use any one of these three given equations. They will help you out to calculate the values. For example, I'm coming back to that's diagram what I have drawn for you people. Let's say that is yes. Suppose this angle is sorry, its refractive index is 1.8, right? This is the medium whose refractive index is 1.8. So what will be the angle of what will be the critical angle? So critical angle will be sine inverse 1 upon 1.8. Yes, कैलकुलेटर से कैलकुलेट करिए जरा जल्दी से शाबाश. Yes, come on, calculate that please.
Approximately 34.
34. Yes, Ariba, did you reach to that point?
Still calculating.
Okay, put the values in the calculator. Shift sign. How do you now that? Sorry, how will you do that? Shift press karo pehle. Then sign. Then bracket. Then 1 upon or 1 divided by 1.8 bracket close. Then you will get the answer.
Sir, I'm getting my answer in a radical.
Okay, I have this. Do you see that calculator?
Yes, sir.
Okay, I will try to fix it. I don't know whether I will be able to do that or not. I have this calculator, but unfortunately, I cannot. Oh, no, this is graphical calculator. Oh my god. Yes. In that one, main memories clear, press menu key. I don't know what to do. Anyhow, shift sign inverse like this, and then you will do bracket 1 divided by 1.8 bracket close. You should get the answer. I will try how to operate this and then I will let you know. Okay. Anyhow, that was 1 upon sine inverse. So you will get 34 degree. ठीक है अरीबा आंसर आ गया तुम्हारा. Yes, Ariba.
Uh, whatever I calculated, I've gotten it in radical, and I don't know how to turn it into degrees.
Oh, you have a button in your calculator. Shift.
Uh,
I'm not using my calculator. Matter of fact, I lost it at school, so now I'm using the one on my phone.
फोन पे ही ना फोन का मुझे. Can you send me the screenshot of that? I have one in my phone. I don't know. Is it scientific? A simple one.
Sir, I'm using the scientific calculator of Google.
Yeah, Google. ये आपको देता है ना? It gives you. Yeah, yeah. Do you know how to convert it?
I use Symbol app. It's on Google website.
Yes, Ariba. Do you use that one?
Not at all, sir.
Okay, okay. Leave it. I will tell you about that. I will send you that a small video by using that calculator. Don't worry. Okay, let's move on. So it means that this calculation is very important for me. It means that if I will incident the light at 43 degrees and degrees, that would become parallel to that glass slab. But if I will incident the light at an angle greater than 43 degree, if angle of incidence is greater than 34 degree, sorry, not 43, 34 degree, then light will not refract. Then total internal reflection will take place. Got it? Total internal reflection will take place. Got it? Is it clear to all of you?
Sir,
Yes.
could you explain that again, please?
Yeah, I'm saying that if I will incident the light at an angle greater than 34 degree, this is the critical angle. Na? So if my light incident on in that medium at an angle greater than 34, then it will not get out of that medium. It would be trapped. It will reflect it back. So that is called total internal reflection.
All right, sir. Thank you.
Got it? So let's say let's calculate the total internal reflection angle of optical fiber. For example, I have an optical fiber over here, right? That is of a glass or any perspex material, and its refractive index is approximately 1.48, right? Its refractive index is 1.48. So calculate critical angle for this one. So critical angle is again sine inverse 1 upon 1.48. Okay. Or wait. Let's do this in another way. I'm not going to give you refractive index right now. If I say that critical angle for this medium, what I'm going to give you is, let's say, 48 degree, then calculate. Hariba, you will calculate that because this is a simple calculator, right? Then calculate n, refractive index of this medium. So how will I use, or which equation will be used? This one, n is equals to 1 upon sine c. N is equals to, so its the solution is n equals 1 upon sine c. Are you getting this thing? So 1 upon sine of 48. Yes, please calculate that. Shabash.
Okay, sir. Calculating it.
Okay. Meanwhile, yeah. Can you confirm me the answer when Ariba will be calculated? Then sorry, Ariba will
Okay.
calculate the answer. Yes.
Just a second. Sir.
Is it negative 1.3?
Let me calculate. Yes,
Not
yeah.
neg. I
It will not
1.3,
negative.
but not negative.
It will not be negative. 1.3. It can be. Yeah, it can be 1.3 sine of 48. It is 1.34. Yes, Ariba, did you get that one?
Yes, sir.
Yeah. So it is 1.34. So this is the refractive index of your optical fiber
Oh,
almost.
actually, both are correct. Minus
Yes.
1.34.
Minus 1.3 is also correct. It is basically 180 plus 48. So what do we do? If we incident the light over here at an angle of, here the angle would be, this is the angle, this angle should be greater than 48. For example, if I am going to incident the light at 50 degree, will that light get out of this optical fiber? Yes. My question is,
Oh,
if the light or laser light incident at 50 degree, will it go out
yeah. C
or
is
not?
critical angle, right?
Yes, C is critical angle, where
Then it
its
won't go
C
out.
is 48 degree. So we are going to incident the light at greater than critical angle. So what will happen? The light will not get out of this. It would be reflected back. It would come at that side. I mean at this angle. Then it would be bounced back over here. Then it would be bounced back over here. And then it would be bounced back over here. For example, this is the only piece of optical fiber. In this way, light will go out of this. Do you agree with that?
Yeah. Yes.
ठीक है, Ariba, is this clear to you?
Yes, sir.
Okay, don't get I mean pressurized and say yes, sir. If it is not clear, I can explain to you again. I mean that when you are going to incident the light at an angle greater than critical angle, देखो, what is the critical angle of this medium? 48 डिग्री. ठीक है, ये जो मीडियम जिसके ऊपर मैं लाइट इंसिडेंट कर रहा हूँ ना, इट्स क्रिटिकल एंगल इज 48 डिग्री. आर यू गेटिंग दिस थिंग? And we described all the stuff that if the light is incident at an angle greater than 48 degree, I mean critical angle, then what will happen? The light will not go back, sorry, light will not come out of the medium, it would be trapped inside. Okay, so it would be reflected back. So when it is reflected back, when it is reflected back, it would hit at this point. So definitely here this angle is again 50 degree, so again it will not get out of that, and so on, and so on, and so on. So it would be basically continuous process. Is this clear now?
Yes, sir.
Good. Now I have another question for you people. I have a prism, like, wait, okay, this is the prism, and I'm going to incident a light at an angle greater than its refractive index, sorry, greater than its critical angle. I will show you that is, this is the normal over here. Okay, so if I give you some data that this angle is 45, what is that angle? 45 degree. Are you getting this thing? This angle is 45 degree. Critical angle for this medium, this blue prism is 42 degree. Got it? Are you people getting this thing? Critical angle मैंने दे दिया हुआ है. So what do you think? Where would the light go? Yes, yeah, yeah.
Yes, sir.
If the critical angle of this prism is 42 degree,
Yes.
and you are going to incident a blue, sorry, green light at an angle of 45 degree to the normal, this is the normal. Okay, this is the normal, this one. Then what do you expect? Where the light would be, what will be the expected path of light? I would draw
To get
few paths.
total internal reflection.
Okay, this is path 1, this is path 2, this is path 2, this is your option A, this is your option B, and let's say this is your option C. Okay, so if I say that this is also 45 degree, so do you think that this would happen?
Uh, the most probably the third one.
Yeah.
Yes.
Will light get out of this prism?
No.
No, light will not become parallel to that. Light would be reflected back in that medium, and here it will come out of that medium. Got it?
Yeah.
This is called your total internal reflecting prism. Now I have the same light over here. Ji. Do you have some questions to discuss? Okay, but I'm getting wind up. Okay, now this is what, this is the light ray. ये light ray इधर आ रही है अभी. So can I say that this is the light ray over here, and if I put another prism in front of that light ray, and that prism is basically placed in such a way that it would be something like this, in this way. So what do you expect? Light would incident over here, okay, and it would reflect back or not? It would reflect back over here. So this is the basic principle of a periscope. So if you have an object over here, right, you will see its image over here. Remember this thing. Got it? Through these prisms are some sort of, we can use some glasses as well, but with the help of these prisms, the light reflects back totally and then it comes in this way. Is it clear to all of you?
Yes.
Okay, good. So the last topic of refraction is refraction through prism. Refraction through prism. So when I say that prism is prism is a part of transparent medium which reflects the light, so we have to know what a prism is. Actually, prism is a sort of glass slab or perspex slab which has two triangular parts and one is, sorry, three rectangular parts. Yes, so when we incident a light, monochromatic light on it, what happens, that light bends, and then when it leaves this surface, it bends again. So this is a way that prism bends the light continuously, right? It means that the light was supposed to pass through in this way, right? What was basically the path of light? The path of light was this one. This was the path of light, but light bent towards the normal. अगर मैं यहाँ normal draw करता हूँ, so what I do, it is the normal over here, normal to this surface, to this position. I mean over here, yeah, it would behave like a normal probably. This is the normal. So, what do you think? If this is the normal, so is that light not bending towards the normal or not? It was supposed to move in this way, but it is bending towards the normal. So in the same way, if I draw a normal over here at this point, this is the normal. So what about this light? It was supposed to move in this way, straight. So it bent away from the normal or not? Because it is denser medium, and when light enters from air to denser, it bends towards, and when it enters from denser to air, it bends away from the normal. So in this way, remember this thing, the light bends down and down and down in this prism. If I consider this, or the light bends towards the base of the prism all the times. This is the base of the prism. Is it clear to all of you? I mean both of you? Okay. So
Yes, sir.
this is called a monochromatic light. Monochromatic light. Chromatic light is the light with single wavelength, single frequency, or single color. A light with mono means single and chrome means color. So in waves or in light, the color is the representative of wavelength. So we can say that monochromatic light means light with single color. Light with single color. Okay, is this clear to all of you? Single color or wavelength, or you can say frequency. So when we incident a single color light, it bends, it deviates, but the emergent light is not parallel to the actual path of light. This is the actual path of light. So as you observe that this is the emergent ray. So they are not parallel to each other as it was happening in the glass slab. So that's why prism causes deviation in the light. So prism cause causes deviation in the light. Deviation in light. Is this clear? According to the wavelength of light. According to wavelengths, or you can say wavelengths are frequency of the light in simple words, or frequency of light. Light with higher frequency is bent at greater angle. Okay, you have to remember this thing. I will explain this in detail. The light with higher frequency, higher frequency, or lower wavelength, or smaller wavelength, sorry, not lower, smaller wavelength is bent more, is bent more. Okay, that means that I have to tell you about the wavelengths of the light rays as well. So we have seven colors over here, and all those seven colors have different wavelengths and different frequencies. So what would be those wavelengths and frequencies? One, two, three, 4, 5, 6, and 7. So this is your violet light, indigo, blue, green, yellow, orange, and red. These are some lights over here. Its wavelength is 400. This is basically wavelength in nanometer, right? And this is its color. So 400, it is of 450, it is of 500, it is of 550, it is of 600, it is of 650, and it is of 700 nanometer. Remember this thing. So red has the highest wavelength, and largest wavelength, and violet has the smallest wavelength. So in this way, wavelength changes. So when we incident a light of two different colors in a prism, for example, I'm going to incident blue light, and I'm going to incident a red light at the same spot. So red light has larger wavelength, so it would bend least, right? This is the red light. But blue light has more frequency or higher frequency, so blue light would bend more in this. A deviation in the blue will be more. So in this way, if I continue this all, so red will be at the top, and so on, violet will be at the bottom. Okay, where will be the violet color? If I incident the violet light at the same angle, what will happen to that? It would be, it would have the largest deviation like this. So it would be violet. So overall, if I say that bending order is red, orange, yellow, green, indigo, and violet. Sorry, after green there is, I think, B, blue, indigo, and violet. So this is your bending order. Violet bends more and red bends least. So if we incident a white light on a prism, you know what will happen? Hmm? Do you know that? No.
Yeah.
When white light is incident on the mirror, sorry, prism, it spreads into seven colors. When white light is incident at prism, it spreads, or it spreads or splits into seven colors. Into seven colors. This is called your dispersion. That is called dispersion of light. Dispersion of light. And order of seven colors is this same one. I have shown you the order. order of dispersion is this one: violet, and then indigo, then blue, then green, then yellow, then orange, and then red. Okay, so if I say that there is a prism and we are going to incident a white light on that, then that prism would basically split this light into seven colors in such a way that, let's say this is a white light, although this is not white light, but it is the combination of red, blue, green, and all that stuff, right? It's just imagine that this is the composite light. We use a word composite light over here. So these are all colors in that light, and when it is incident on the prism, red will be at the top, and red will be at the top while bending it down, and violet will be at the bottom, and then violet will be at the bottom. Okay, so here it would be V, I, B, G, Y, O, and R. This all would be actually V, I, B, G, Y, O, and R. This would happen inside the prism when there is a white light. So there are seven colors actually. Okay, green will be at this point, and I have blue color as well. So blue will be at this one. So I have not all those colors available, but that is the dispersion of light. Is it clear?
Yes.
Yes. So that's it for today. Any question?
No, sir.
No, sir.
If I send you some sort of worksheet for that one, so will you people be able to do that?
Yeah. Yes,
Maybe,
probably.
maybe not, because I have exams, sir.
Okay. So yeah, will do that, inshallah. Yeah.
Inshallah.
So if I will have 50% response, one of the student will do